2/3, 1/3. If you notice, right, it's both still low pass filters, okay? 1/2 is average, so low pass filter. 2/3, 1/3 is still a low pass filter. Not a very good one, but still low pass. Okay? So let's see what happens here. C I equals 1, T equal to 2/3, so I'll give me 4/3, Ci 2T plus 2/3 Vi of 2T minus 1. Is that clear? I'm doing okay. So let's start with this. What is Phi1 equal to? Phi0 2T, which is this, string in, right? And scale by 4/3. So you have 4/3 to 1/2, right? And then you have 2/3, okay? 1. This is Phi1. What's the next step? The next step, Phi2, okay? Second iteration is based on the first iteration, based on this solution. Right? So I'm going to take this one here, I'll shrink it in, and scale by 4/3. Right? And then shift, scale by 2/3. Okay? So using this solution for the second iteration, we have, let's see, 1, 2, 3, 4, right? 1, which is Phi second. Okay. Second iteration. What do I get? 69, right? So it's 4/3 square. Okay? So it will be 4/3 square. So 69. What's the next one? 49. 89, right? Because 4/3 times this. So it's 89. Okay, so this is this. 4/3, 3 of 1, 2, 3. And then 2/3, 3, 1 of 2, 3 minus 1 would be this, shift, by scale in, shift, and then scale by 2/3. So tell me what is it? 49? 89? Right? Okay? So tell me, if I go to infinity, what kind of curve do you have? What is the limit of this go to infinity? Is it stable? Is it bounded? Who thinks it's bounded? Who thinks it's not bounded? It's not bounded. Why it's not bounded? Because if this is 4/3 square, what is 2? What is this value? What is it? 3? 4/3 cube, right? 4/3 bigger than 1. Is it that goes to infinity? So this is the case where there's no solution, no bounded solution, right? Okay, you have infinity. Okay, so this is the case where there's no solution. So there's some kind of a extra condition on the filter H0 such that we have a solution. So can you compare these two choices? Both are low pass filters, right? Why is one converge and one does not converge? So I'm just putting a cross here. It's not convergent, right? No solution. So what is the difference between these two choices? Such that one you have a solution and one you will not have a solution. Can I solve this one? If I plot whole 0 pi. Where's the 0 for this one? At pi, right? At minus 1, because you have 1/2 and 1 to the inverse. So when z equal to minus 1, you have a 0. There's 1 0 here. Is there a 0 at pi here? No. You see that there's no 0 on the frequency, right? On the unit circle. So that's what you need. This is called condition approximating P, or AP in the book. For approximation with degree T. The number of 0 at pi dictates your approximation. If you have 1 0 at pi, you can approximate piecewise constant signal. If you have 2 0 at pi, you can approximate piecewise linear signal. If you have 3 0 at pi, you can have quadratic. 4 will be, third power, so forth. So you can, we're not going to prove it. Okay, it's in chapter 7 of the book. But here's what you should remember. You should remember is the correlation between the 0 at pi to the approximation. Let me make a short table here. P, okay, and the approximation. If P is 1, you can approximate piecewise constant. If P is 2, you can have piecewise linear. So you can have T. If P is 3, you can approximate a constant, that is constant 1, a constant, piecewise linear, and piecewise quadratic, and so on. Okay, you have 4. You can approximate any function. You can represent it by 1 t squared t cubed. If you recall the first few lectures, we have example where this is 4 0 pi and so on and so forth, right? And those are the ones that people use. If we want to have, a decomposition, a useful one. Useful in the sense that you be able to capture, represent exactly, right? Piecewise constant, piecewise linear, quadratic, cubic, and so on and so forth. So there's a proof in the book saying that if you have, p 0 pi, you can actually represent piecewise up to t to the p minus 1 order function. Okay? So that's what you should remember. If you're interested in the proof, you can look at proof in the book. Okay? And if you have questions, email me. Next example. One quarter, 1/2, 1/4. So this is my coefficient x naught, okay? So far we discussed 2 types, right? Solution, now we have 3 types. So instead of having 2 terms, how many terms do I have? 3 terms. So let's write it like that, okay? So I have 3 of I plus 1, t, 1/2, right? 1/4 times 2 is 1/2. 3i, 2t, and 1, 3i, 2t minus 1,